To solve a system of equations means to find values for all of its variables that will solve all of its equations at the same time. One technique we can use to accomplish this task is the technique called elimination. In the elimination technique, we will try to add or subtract one or more equations from each other in such a way as to cancel out a variable and give us fewer variables that we can then hope to solve for. In this example, let's look at both of the equations that we begin with, 2x plus y equals 1 and 4x minus 2y equals negative 10, and discover a way of perhaps altering one of the equations in a form that will permit us to cancel one of its variables when it is added to the other. Let's focus in on the y in the first equation. If we were to multiply the first equation by 2, then the coefficient of y in the first equation would be positive 2. The coefficient of y in the second equation is negative 2. And because those are equal and opposite to one another, we would, if we were to add these two equations together, eliminate the y from the resulting sum. So the first step in an elimination problem is figuring out how to multiply either one equation or both equations if necessary in such a way as to make the coefficients of one of their variables equal and opposite. Here we'll multiply both sides of the first equation by 2. So the left-hand side of the first equation becomes 4x plus 2y. The right-hand side becomes 2. The second equation we will leave by itself, 4x minus 2y equals negative 10. Now that we have balanced out the coefficients of y so that they are opposite in both equations, we can eliminate y by adding those two equations together. Here we're adding because we want the resulting coefficient of y when we combine like terms to be 0, which we can obtain by adding positive 2 and negative 2. But we cannot simply add those terms by themselves. We have to also add together the x terms in these equations and add together the constant terms on the other side of these equations as well. So adding these two equations to each other gives us a new single equation, 4x plus 4x, 8x, plus 2 minus 2, 0, y, equals, on the right-hand side, 2 plus negative 10, which is negative 8. Thankfully, and this was the whole point, the coefficient of y being 0 in this new equation allows us to remove that term completely and gives us an equation only involving x, which we can then solve simply by dividing by 8 on both sides. So now we've discovered a value for the variable x by adding the two equations together in a way that eliminates y, and then solving the result. Now that we know what specific value x takes, the end game is the same as with any other technique of solving a system of equations. We can plug this specific x value back into any of the original equations that related x to y, and then use that equation to discover the value y must take. If I plug x equals negative 1 back into the original equation, 2x plus y equals 1, then the equation that I obtain is negative 2 plus y equals 1, which we may solve, adding 2 to both sides, to discover y equals 3. Therefore, the solution of this system of equations is the values x equals negative 1 and y equals 3. So to solve a system of equations using the process of elimination, the trickiest and least obvious step is probably the first one, figuring out how to multiply either one equation or more than one equation in such a way that the coefficients of one of the variables balances the other out, in a way that when the equations are added, that coefficient becomes 0 and that variable gets eliminated. In this example, we saw that if we multiplied the first equation by 2, then the y term in the first equation would become 2y. The y term in the second equation was negative 2y. And so when the equations were added together, the y terms would cancel out altogether. Doing so gives us an equation with only x in it, which we may solve to find a specific value for x, and then plug that specific value back into an original equation